Hello, continuing our work in geometry, we're having another look at planes, points and lines, and I have drawn a plane in here. So obviously we know a plane goes on forever, it's infinitely big, but I have drawn a piece of a plane here. So that's what I've drawn here in my little box in the left hand side of my screen. And I've put some points, or rather I've highlighted some points on my plane. So we know the plane is infinitely big. It's an infinitely big sheet of paper, and it's made of lots of little points. And I have highlighted some of those points. And now we're going to have a look at some of the notation connected with our coordinates of our points in general. So we're going to start off up here. What point, it should just be point, what point is labeled wrong? So if we look at my diagram, which one of these points is labeled wrong? And I can see that B is labeled wrong. Why is it labeled wrong? Because I have a small letter for a point, and I know I should use capital letters for a point. So actually, just so it's clear for you writing your notes, I'm going to put a line through that, and we're going to say B. That should be capital letter B, not small letter b. So which point is labeled wrong? B should be capital B. It's more like 13. So I'll rewrite that. So that's my first point. I know that capital letters are what I have to use for my points. And as an aside, you need to be, well, not totally need to be, but it's a good idea to be aware that I've drawn these points as fairly big blobs on the screen, so they're fairly easy to see. A point is technically infinitely small. It has no size. That doesn't make a huge amount of physical sense, but it's important for some parts of mathematics that our plane can have any coordinates that we like, and because our points are what make up the plane, they must be infinitely small. So technically, a point is infinitely small. It has no size. Now, let's get into a slightly more practical question. Is C something of this? Well, we need to do a little bit of translation. What does this symbol mean? Well, it's from sets that we've seen this before, and it means element. So is the point C an element of this? Well, what is this? This is a ray. It's a line that starts at E. I have a cap sitting next to E, so it starts at E and it goes on past D. So let's draw this in on my diagram. I can see here now that I have my blue line is the ray ED. Again, a ray is where we start at a point, we go through a point, and we continue on past that point. So is C an element of the ray ED? Yes, it is, because C is one of the points on our line. We can see that that the blue line goes through C. So C is an element of that set. Remember, lines are sets of points. There are a whole bunch of points that all sit together in a straight line. So they're in a group, so they are a set. So yes. Sorry, I need to write that in red. C is on ED. Now, next question. Is C an element of DE? Well, what does DE look like? Let's draw it in. So here we have our red line going as the ray DE. So there's a cap, a square bracket at D. So our line starts at D and goes on out through E. So C isn't on that line. The red line never goes through the point C. So we'd say, no, it's not on that point. Next, how many elements has AC? Well, where's AC? Let's draw in AC. Well, AC is our red line here that goes through the points A and C. So I take my ruler and I draw a line and it's going to go all the way up that way and all the way up that way. It keeps on going forever, just like our ray keeps on going forever out past D through C. Now, how many elements has AC? Remember, AC is a line, so it's a set of points. There's a whole bunch of points all along this line, and there are an infinite number of them. So there are an infinite number of points or an infinite number of elements on AC. There are an infinite number of points that we could dot out on the line AC. So it's an infinite set, and it's a subset of the plane, if we remember correctly, because it's a set within a set. Now, next is AC is this symbol around AC equal to this symbol around AB is plus this symbol around BC. So what do our lines on either side of our points mean? Well, this means length. So what we're looking at is this length here, if we measure it with our ruler, that would be the length AC, and then the length from A to B is going to be this length here, and the length from B to C would be the length BC. So we know our straight lines on either side of our points mean that we are getting the length of something. So when I measure this, I find that AC is equal to 5 centimeters on my ruler. Obviously be different for you on your screens. AB is 2 centimeters and BC is 3 centimeters. So I find that 5 centimeters is equal to 5 centimeters. So yes, but in general, I don't actually need to do that check. I wouldn't need to measure it usually. If they ask you to in an exam, then by all means measure it with your rulers and write down the measurements and do exactly what I did here. But in general, you will know by just looking at the picture, this total length here has to be made up of the length between A and B plus the length from B to C. Logically, there's no way that they can't be equal to each other. This total distance is the same as this total distance. They are the same thing. So we need to know that our lines can be broken up in this way. It will be very important in the long run. Next one. What is AB and then an upside down new looking thing, DE? Well, AB is a line. So it's the line going through AB. It's my red line here. DE would be the complete line. So my blue line that I've written in here is a ray. The line DE would keep on going up in this direction forever. So what does my sign in the middle mean? It means intersection. So I'm asking what is the intersection of AB and DE. So this means, again, intersection. This is my intersection between A, B, and DE. That means what point is on both lines? What point is in growth groups? What point is on both lines? Well, that's going to be C. So C is the, sorry, we need our curly brackets because that is a set, or it's an, yeah, that's a set. So the intersection of AB and DE, my red and my blue lines, effectively, is the point C. That's the point that where they cross each other, so that's the only point that's in both groups, in both sets. So I'm going to write that down for you. So the point C is in both sets, and it is on both lines. Those are two ways of saying the same thing. Next one is the ray CD. So the ray CD, so our ray starting at C and going off out past D, a subset, our long C here is subset of CD. CD would be the complete line going everywhere from down here all the way up past outside our box. And yes, that would be true. The ray CD is a set that is contains all of the points. CD contains all of the points that the ray CD has. So CD is bigger because it keeps on going past C, but it contains all the same points as the ray CD. So yes, the ray CD is a smaller group within the bigger group of the complete line CD. Next, what is the length of AB? Well, AB is our line that keeps on going this way and this way through the points A and B. And it has infinite length. It keeps going forever. Length. So it has an infinite length. We can't measure it with our ruler, it just keeps on going forever. And then finally, what is the length of this business here? Well, I have a square bracket capping off A and a square bracket capping off B. So this is a line segment. It's a part of a line going from A to B. So how would I write the length of the line segment AB? Well, I already know that as AB with our straight lines in between, and I measured that earlier, and it's 2 centimeters. So that is what I need for being able to deal with my lines and points, and we know that they're all drawn on our big plane, and that's what we need.